Welcome back. We're determining if a given relation is a function. In the previous section, we were given a set of points that describes a relation, and we wanted to find out if that indeed is a function. Well, in this section, we're going to be given a table of values, and we want to find out if that describes a function. So let's take a look at a few examples. Let's say we're given the following table. So we have a table of values. We're given a table of x values and y values. Y values are the same as f of x. The x values are -2, 1, 0, 1, and 2. And the y values, or the f of x values, are 4, 1, 0, 1, and 4. So this is a relation, and I guess I shouldn't have written this as f of x because we're determining if this is a function, and f of x is functional notation, so I don't want to confuse you there. So let's just say our x and our y values are described by this table. Okay, so the first thing we want to do, in the previous section we found out that if each x value, each input, has a unique output, a unique y value, then that is what we call one-to-one. We have one input for one output. 1-to-1. This is kind of important. If we have one-to-one relationship in a relation, then what we have is a function. So we want to look at all our x values, and we want to see if any of them appear more than once. Well, here we have two x values of 1. And this is okay as long as each value of x equals 1 gives us the same y value. And indeed it does. They both equal 1. So what this is called is one-to-one, and that means that this table describes a function. So this is indeed a function. All right, let's take a look at a few more. Let's say we have the table of values of x and y. The x values are 2, 0, 3, 2, and 0. And we're given the y values are 8, 2, 4, 12, and 2. Okay, so what are we looking for? We want to find that if we have an x value appearing more than once. Here we have 2 appearing more than once, and that's okay as long as that gives us the same output, the same y value each time. But here is not the case. The x value of 2 gives us two different outputs. It gives us 8 and it gives us 12. Okay, so this is not an example of being one-to-one, so this is not a function. Not a function. Now notice we also have another x value appearing more than once, and that's 0. Now here, the x value of 0 gives us the same y value, the same output, which would be okay if that was the only x value that was repeated. This would actually be a function, but 2 appears twice for our x value and gives us two different values. So as long as we have at least one x value that gives us two different outputs, then we do not have a function. Okay, so I just want to be clear about that. Let's look at the next one. Let's say we're given a table of values where the, oh, it's a little too light for me, where the x values are 0, 1, 2, 3, and 4. Our y values are given as 2, 3, 4, 5, and 6. And we want to know if this particular relation is a function. Well, what we're going to want to look for is if we have any x values that are repeated. And here we actually don't have any x values repeated, which we don't have to do anything else. We have a one-to-one relation. For each x value, we have a unique y value. So that means we have a function. We have a function. All right, let's look at one more. Let's say we are given the following table of values. Here we're given the number of hours, could be number of hours worked. In this case, let's say our dependent variable is the number of movies watched. Okay, so we're given the number of hours for the number of movies watched. All right, this is sort of a real-world application of determining if the relation is a function. So let's say our number of hours are 0, 1.5, 3.5, 7, 9, and 10. All right, so for these number of values, we're going to say that we watched the following number of movies. Watched 0, 1, 2, 4, 5, and 5. Okay, so the first thing we want to look for is if any of our x values appear more than once. This is our x values, and this is a table of our y values. We're just defining our variables as hours and movies watched. We can also call our x values t, because we're talking about time here. Either one would work, it really doesn't matter. But as long as our t values here are used, we want to know if any of them are used more than once. And if so, they need to give us the same output for this to be a function. Here we don't have any number of hours or any values of t repeated, so we can go ahead and say that this is indeed a function. Now if you noticed, over here we have two particular instances where we have a value of 5 for our output, or we have 5 movies watched. And that's okay, because in 9 hours we watched 5 movies, and in 10 hours, after 10 hours we watched 5 movies. So maybe we took a break between the 9th hour and the 10th hour. That's okay, because it actually, if you think about it, it makes sense. But as long as we don't have the same number of time, let's say we had, during hour 7, we had watched 4 movies, and also during hour 7 we watched 6 movies. That doesn't make sense. So we definitely wouldn't have a function. So if we think about actually the theoretical side of a function, it tends to make sense. So if it makes sense, it's usually true mathematically. Usually, not always. Some situations are counterintuitive, and we'll look at those later on. But we're actually using tables, and we're using the information from tables to decide if we actually have a relation that is indeed a function. So we'll look at one more case in the next section. I'll see you soon.